Now you know about users and groups. So the fundamental reason behind creating users and attaching them to the groups is to create a certain kind of restrictions and permissions and conditions in accessing the resources of that system. So that's where the permissions comes into the picture. So it's time to decode the cryptic file permissions you have seen when using the ls command. This section describes, the slide basically talks about how to decipher the permissions and where they come from. So this is how it looks that you have seen before. For that, what I will do is I will take up the lyrics. Yeah, this one. Okay. So now the see clear the screen first, and then ls lrt. We will take. Yeah. Anyway, we have very few files. So now after doing ls lrt in this, we have three files in it. So if you look into this long listing file, the first field in the output listing is a code that describes the permissions for the files and directories. The first character, this is the first character. Is it clearly visible for you? This is the first character on the leftmost. The first character in the field defines the type of the object. Basically, for just a dash for files, and D for directories, L for links, C for character devices, and B for block devices, N for network devices. Then after that, you see three, you see the three characters. Each set of three characters defines an access permission triplet. So this is the first triplet, this is the second triplet, this is our first triplet, this is our second triplet, and this is our third triplet. These three triplets basically defines an access permission for three different types of users. So the first one the first one, we have R, W, and X. The in this, the R is for read permission for the object, and W is for write permission for the object, and X for execute permission for the object. So if a permission is denied, if a permission is denied, a dash appears in the location. A dash appears in the location. That's what here you can clearly see. So a dash dash dash, that means here execution permission is denied. A write execution, both permissions are denied. So the three sets relate the three levels of security for the object. So the first triplet the first triplet related to the owner of the object. Then the second triplet group that owns the object, and the third triplet, everyone else on the system. These are the three triplets uh, permission system of Linux. So this the first triplet anyway, the first dash, it defines the type of the object, and then this is the first triplet that talks about the permissions for the file owner. So here it's RWX, that means owner has read, write, execution permission for that file. And the second triplet is permissions for the group members, where this owner is associated. So it also has a read, write, and execution permission. And the third triplet is permissions for everyone else other than owner, and then group members which are associated with the owner. Other than these people, everyone else will have these permissions. Of course, RWX, these also have a read, write, execution permission. So other than that, the remaining components of this has been explained before itself. So Linux file permission codes are goes like below. First one is dash. Dash means no permission. So binary it's a triple zero, and octal it's 0. So we'll look into the octal ones. Whereas double dash X, for example, this is basically a triplet execute only permission. When it is a double dash X, no read, no write, execute only permission. If it is dash W dash means write only permission, and dash WX write and execute permission. R double dash means read only permission. R dash X read and execute permission. RW dash read and write permission. RWX all permissions are given. Read, write, and execute. Basically, this is in binary form. When these are, of course, we are doing it using these alphabets and dash. However, the system understands this in a binary form. This is what happens. So next, we will look into the changing the permission. Now we have seen how that permission works, but now we have to do some modifications in the permission. You want to give access to your group members or the other members which are neither in your group. So how will you do that? If you have already created a file or a directory and need to change the security settings on it, Linux has a few different utilities available for this. This section or this slide shows you how to change the existing permissions, the default owner, and the default group settings for a file or a directory. So let's begin with the chmod. Chmod, change mode. Chmod command allows you to change the security settings for files and directories. The format for the chmod command is clearly visible on your screen. So chmod, this is the main command. After that, you can have you can have options, and after that mode, which mode you want to have, and then file. This is your argument. This is your argument. So the mode parameter this mode parameter allows you to set the security settings using either octal or symbolic mode. We have to decide whether you want to go with the octal mode or symbolic mode. The octal mode settings are pretty straightforward. Just use the standard 3-digit octal code. Octal code you want the file to have. So example, this is a 760. That's a file1.txt 760 example. Okay, but before that, let's go get back to the previous slide and see octal codes. For only execution, the octal code is 1, and for only writing, the octal code is 2, and for only reading, the actual octal code is 4. So 1, 2, 4. 0 no for permission, 1 execution, 2 writing, 4 read. This is what the octal code. I want you to remind you one more time. So when you say 7, you give read, write, execute all permission. When you say 6, read, write permission. When you say 5, read and uh, read and execute permission. So these are the things we are going to use now. Okay, so now let's do a small let's use, I think it's got clear. Okay, let me clear this screen first. I'll log into it, then I'll clear the screen, then I'll become sudo. So I'll clear the screen again. Now, so where I am, pwd, so I'm in the root. I will enter into the tmp. Yes, so there are a lot of files here. So I'll create one more file, one more directory, mkdir, and this is Linux security. Linux sec. So cd Linux sec. Okay, that's wrong. Nothing is there. So let me clear the screen, and then let's touch the files here. Touch file and square curly braces 1, 2, 3 and .txt. So now 3, okay, ls 3 files has been created: file1.txt, file2.txt, file3.txt, and file type of each one should be yes. Okay, these are .txt files. So now let us check. For Warner, read, write, execute. For group members, read only. For others, also read only. These are the permissions that are available. Now, how will you change? Chmod 760. 7 for the Warner, 6 for the group, and 0 for others. So here, I want to give all permissions to Warner, and read and executable permission to read and write permissions to our group members, and no permission at all, no permission at all for the others. Let's see how can we do that. For that, chmod 760 and then file1.txt. Now we'll do the same thing and check. See the magic. This remains same, this remains same, but file1.txt, just compare this. Here we have file1.txt, and then here we have file1.txt. After changing the permissions, for Warner you gave all permissions. For group members, you gave only read, write permission, no execution permission, and for the others, completely 0 permissions. This is how you can change the permissions using octal members. So now, instead of using the normal string of 3 sets of 3 characters, the chmod command takes a different approach. The following is the format for specifying a permission in symbolic mode. So you can see this, you can see it on screen. You have 3 sets of characters in 3 square brackets, 3 closed square brackets. First one makes perfectly good sense, doesn't it? So the first group of characters defines to whom the new permissions apply. This first group of character, this part. And then next, a symbol. A symbol is used to indicate whether you want to add the permission to the existing permissions, that's plus, or subtract the permission from the existing permission, that is minus, or set the permissions to the value, that's equal, equal to. And the finally the third symbol is the permission used for the setting. You may notice that there are more than the normal R, W, X values here. These are the additional settings. X assigns the execute permission, and S sets the UID or GID on the execution. T saves the program text. U sets the permission to the owner's permission. G sets the permission to the group's permission. O sets the permission to the other's permission other than RWX. And here you see U for the user, G for the group, O for the others, A for the all of the above. And RWX is anyway common. Other than that, you have additional settings and plus and minus and equal. Now, using these permissions looks like below. You can see that on the screen. The first example, chmod, the O plus R entry adds the read permission to whatever permission the everyone security level already had. O for others. So add a read permission to the others. That's it. Okay. Then the next example will take the U minus X. The U minus X entry removes the execute permissions that the user already had. Note that the minus F option for the ls command indicates whether a file has execution permissions by adding the asterisk to the file name. And so what we'll do is we will test once. Let's get into this. Clear and cd tmp ls. Okay, so we have file1.txt, out of which let me check ls lrt. We'll select one. So Kantara lyrics, for example, this one we will take it. Here it doesn't have write and execute permission for the group members as well as others. Now what I want to add is I want to add write executed permission for the others. For that, chmod O plus X and then file name is Kantara lyrics. Now let's check ls lrt. Here it is. There is a change. Here it is. It's the X has been added. Here there is no X for the Kantara lyrics. No X and X. That's how you can change for specifically. Anyway, you can remove it also. We will use the same one. Put minus and remove the execute permission, or you remove the read permission. That's it, gone. Here read, here no read, here there is a read permission for the Kantara lyrics. Okay, that's what I'm trying to prove here. So we did it. So next, changing the ownership. This is also very important. Sometimes you need to change the owner of a file itself. In that case, what will you do? In such a case, when someone leaves an organization or a developer creates an application that needs to be owned by a system account when it is in production. So Linux provides two commands for doing that. One is the chown, the most famous one. Chown command makes it easy to change the owner of a file, and the chgroup command allows you to change the default group of a file. So these are the two examples. For example, if you check, all these files are created by root user only, so there is nothing much to do here. But still, if you want to change the ch1, okay, there is a wrong ch1, and then charan, if it is there, kantara lyrics, I think, yeah, it's got charan, that's it. It's changed. The owner of the file itself is changed. That's how it works. So now we will specifically look into changing permissions in numeric method. So for that we use a 3-digit mode number. It's actually octa that we have discussed earlier. First digit specifies owner's permissions. Second digit specifies group permission. Third digit represents others permissions. So permissions are calculated by adding the numbers. Okay. For the read, that we have seen before, only read, and one for write, one for execute and two for write. Now for example, chmod 640 means for owner give read and write permission, and for the group members give only read, and for others no permission at all. So let's do it. uh Clear. Okay. Mhm. So ls, I think I'm in home. cdtmp, yeah, there are a lot of files. Let me do lslrt. For example, okay, this one has a read, write, and no execute and this permission. So what I have to do is I want to make chmod 640. So 640, the owner should have only two, that's a read and a write, no execute permission. And then for group members only read, and for others zero permission. So that, then in that case I will select this one, rw. Okay. I think this one would be better, this Jenkins one. So let me check. Clear ch mode 640 and Jenkins. That's okay. That's okay. I will do it. Don't worry. Ch mode 640 Jenkins. Where I am? Okay. cdtmp. Clear again. Ch mode 640 and Jenkins. ls lrt. Where is Jenkins? Yeah, here it is. Jenkins. Yeah. Read, write, and then only read for the group members, and no permission at all for others. That's how you can use the numbers, even to change the settings. So now what will we do is, before we close up these permissions slide, let's do a detailed exercise for this. Okay, so let's begin in the same Ubuntu. Here, let's change the permissions using letters first, and then we will change the permission using the numbers. So in here in tmp I will create a directory, the parental directory, that's opt, sorry, I DevOps dir, then enter into that. Okay, so now let me add some groups. Group add iDevOps, and then user add Ansible, user add Jenkins, user add, okay, it's fine, AWS, it's also existed, no, it's not that. So and finally add user, this is a regular user, Rama. Okay, new password, and this one, and after that we will have a room number. So work phone, you can give anything, and the home phone same, and others information, and finally click on Y. Yes, it's done. So now after adding the users and group, so it's time to check the group files, so that we can clearly see whether this group has been added to it or not, and similarly these users has been added it or not. So let me do vim to see the file, and etc, and then sorry, etc and group. Here you can see iDevOps is your group, and all of the files are also there, so it's clear. So now you can just get out of this pod itself, and you can, if you want to check, you can cross check it, id Ansible. That's it. So now let's do some changes. Let's do some permission changes. So ls ld, okay, now let's create some files. Touch file 1 5 dot txt, and then let me click on enter. So let me check lsld. Yeah, now how many files are there? Okay, ls, yeah, we got the files, total 5 files are there. So when I do long listing ls lrt, so we have total 5 files are here, and now I will do the changes one by one. So the first one, ch won, and capital R recursive, and then Ansible attached to the DevOps group, and then DevOps dir. So we haven't added the DevOps group to the Ansible to the DevOps group. That's fine. So now we'll start changing the permissions. So ls lrt, and we'll check each file. For example, I'll get one step behind. So now ls lrt, ls lrt now. So iDevOps, this is the one here. uh, Read write execute permission for all, for owner, and read and execute permission for group members, and read execute permission for the others also, but no write permission for the group members and others. Now what I will do is I want to remove execute permission for the others. They I don't want other people other than who are in my group uh, entering or executing anything in my folder. So that's what I want to do. For that, what I have to do is chmod 0 -x, and then iDevOps dir. Now let's check lslrt again. Here it is. It's been removed. Execute permission for others has been removed. So that's how you can take out the permissions, access to the other members who are there in your system. So now I want to remove even the read permission for the other members. So how will I do? Same thing. chmod wo -r, and then iDevOps dir. Let's check it again. Here it is. Even the read permissions are also has been removed for others. So even they cannot read, they cannot write, they cannot execute, they cannot do anything in my directory. So that's how I can limit the access to other members of the other users of the system to read, write, access my directories. And chmod, let me clear this. Chmod and then group, this is for the group member. Add write access to the group members for DevOps dir. Sorry, iDevOps dir. Now let me check it. LRT, yes it is. Yes, you got it. So I gave a right access to the group members whom with I associated. So that's how I can give accesses. I can take out the access to my directories because I am the owner of it. So that's it. So now let's move on to another component, another part of this session, that is changing permissions using numbers. Changing permissions using numbers. Okay, so for that we'll create one more directory, that is mkdir opt and then web data. Just a sample, anything. Okay, so the directory has been created. Now let's check lsld opt web data. Yes, this is the information about that, and these are the permission levels of the web data directory. You can clearly see it's a directory, and the owner has a read, write, execute permission. Group members has a read and execute permission, not write permission, and others has a read and execute permission. Now I want to limit these people. So how can I do? So first thing I will do is chmod 7 7 means read, write, execute permission for the owner, and 7 read, write, execute permission for the group member, and 0 no permission at all for the others who are not part of my group. Sorry. So chmod 770 and then opt web data. This is the directory where I want to do. So let me check it again. Here it is. All access has been removed for the others. For owner, read, write, execution, And for the group members, we have even given the execution, write permission. Here there is no write permission, but after the change we gave the write permission. And whereas for the user, for others they used to be read and execute permission, now we have removed those also. That's how with a simple one line command you can take out or give the permissions. So then we will do a funnier task, chmod. Let's give all zeros and do and see what's going to happen. let's do, let's take it as per your intuitive. What's going to happen? Boom, all gone. No permissions for owner, no access to the group members, no access to the others also. This is how. Now if you want to bring it back all the permissions, if you want to restore all the permission, again chmod 777 all for all, uh, and then opt web data. Let's check it again. Here it is, green. It is for all. Read, write, execute permission for owner. Read, write, execute permission for the group. Read, write, execute permission for others also. We have opened it to everybody. So that's it. You just keep practicing it. It would be very helpful for a that system administrator. Not only that, for ML engineer and ML ops guy also, it's very much pretty much important, this concept. So you just go through it.